Hi, thanks for coming. I wanted to explain today how all this energy that's going to strike the Earth in 2012 gets accumulated. And I made a couple of drawings. This is figure 1 here, figure 2. Figure 1, I'm going to explain just the stars behind the black hole that extends out to infinity in the galaxy, gets concentrated on the Earth by the way of the sun. So here's the black hole, here's the sun, and here's the Earth. This is not to scale. Okay, so I'm going to start with a light that's behind the sun, and here you can see this line here is directly behind both the sun and the black hole. Okay, so now this light from this green star comes along and doesn't go in through the black hole because it won't come out, but it gets bent by the gravitational at this, what's called this, I don't remember what the exact name is, but this is the black hole is actually much smaller. This is the barrier at which light enters into the black hole and doesn't come out. So it bends it, but just outside this, it bends it and makes it go towards the sun. Otherwise, it would have gone on straight. Okay, so then it comes down to the gravitational pull of the sun, gets bent again, and gets down collected at the Earth. Okay, here's another star. It doesn't come to the exact point where it gets bent as the green one, but it also gets bent. It's maybe only 1,000,000 miles across. That whole area that affects it and sends it to the sun. Okay, so this brown or orangey brown comes and gets bent into the same path, and then that gets bent by the sun again. Here's one right along the center. It also gets bent, and you can see it over on this side here. So so instead of having just those tiny, see in this figure 2 here, here's the 1 times from the small star, millions and billions of light years away even, and it's only got 1 times. That's the light that would strike the Earth if it actually could see it. But what happens is, a lot of the photons that come and hit the black star, the black hole, actually get bent. So on figure 2 here, this is the outside edge of the black hole. Here's all the points of light. Okay, and the amount of light could be 1,000,000, could be 1,000,000,000, because it depends on the angle that this makes to us. And then if you multiply all the angles that are along here, you get 10 to the 6th or even 10 to the 12th magnification. Just depends how far away it is, what the angle it makes with the thing here. There are, see, if a star is right here, very close, it would still make an impression, but not as much as one that's back here in the center further back, like that. Okay, so this represents the black hole and the light energy around it. But as you can see from here, there's a cone being created of energy. There's no energy in here, and there's no energy here. It's all concentrated into this cone. Now the Earth, in traveling around the sun, will actually intersect this cone of energy, but it's only for a very short duration, and it's not been concentrated like behind the sun. So behind the sun, all the energy comes here, but this energy here doesn't strike the Earth as it travels through the year. There's always an effect, but it's very small. But if we go to the Earth, when it hits this alignment, it's going to be another 10 to 12 times. So it could actually be the same amount of energy as the sun is going to the Earth. We just don't see it until we get to every 26,000 years. Anyway, I know this is a lot of information, but you can go back and replay it. And if you have questions, of course, you can email me. Thank you.